All right, so we're trying to do 6.2 number 20, for which I've got a massive 1 kilogram stretching a spring 49 centimeters in equilibrium. It's attached to a dash pot that supplies a damping force of 4 newtons. And I'm supposed to find the steady state component of its displacement if it's subjected to some external forcing. I guess I have some lookup to do. Because dash pot?
Yeah.
I don't know. I'm gonna just go ahead and get myself a Chrome window here. What the hell is my Chrome window? Get myself a Chrome window here. And we're just gonna Google the word dashpot. Because I've never had the opportunity to look at a picture of a dashpot in class before, so this is fun. Dashpot, Wikipedia. Why didn't I just open the Wikipedia article? Oh, it's just straight up a shock absorber. Oh, look, you can order them. I guarantee you that's from a website selling dashbots.
Got motion.
Oh, I love the internet. It's so funny. All right. So, at any rate, it's some kind of shock absorbing thing. In this case, this is basically just their way of adding friction to the system. Okay, so if I'm pulling items in here, let's see. In order to do this, I need my kind of spring equation, right? So I'm like, all right, so my double prime plus by prime plus ky is f external.
That's weird.
Just kind of,
your writing isn't showing up on my screen.
oh.
Like I can see your OneNote, and I see your mouse. There it is.
Did you say there it is right as I closed it?
I saw like half of your equation.
How about now?
There we go. Yeah.
Okay. All right. So now some of these things I think I know. Mass.
Mm-hmm.
What's a mass?
1 kilogram.
1. Okay. What is the damping force?
It's 4.
4. Okay.
Which is in units of kilograms per second. Just so we can keep track of units this time.
I don't want to keep track of units. I don't like units. I'm
So-
a mathematician.
We had too many issues with that last time, Joe.
Yeah.
The reason why we know the 4 goes in place of the B coefficient is because it tells us meters per second, which is the first derivative.
Sure. That's a totally.
You could actually. So the force, since the force is 4 newtons, it's 4 equals c times 1 meters per second. So you can solve by dividing 1 and you get c, which is the dampening constant. So, yeah. Because if it said it was 4 newtons for every 2 meters per second, then it would be 2.
Yeah. So what I'm looking at here is, right, it's 4 newtons for each meter second of speed. Right? So that's 4 times the speed is the damping force, and that's this guy.
Mm-hmm.
This thing total, by prime, is the total damping force. Right, so I've got my 4 times my speed. All right, and then this ky should be the spring force. So I need to know what the spring constant is. And my guess is that the problem that I'm going to run into is that this is in centimeters and this is in meters.
Oh my god, I just realized what I did wrong. So dumb. I put the 49 centimeters as my K.
Yeah, and I think it should be 0.49.
Oh no, it shouldn't. It should be something else because that's the distance, not the. Well,
Yeah.
I did have 0.49, but that's still not right.
Okay, so let's go figure it out. So with the what the mass. Oh, sorry, I forgot
No,
gravity.
it is right.
That's my problem. So my mass of 1 kilogram stretches this spring 49 centimeters in equilibrium. So I'm going to ditch 49 centimeters and put 0.49 meters, right? And then I'm going to think to myself, okay, so in equilibrium, right? That means 0 is the spring force plus the gravity force, and they are going to tend to point in opposite directions. Gravity being a 9.8.
It's weird. There's like a really long delay on your writing. Like all I see, your equation is just not popping up.
I don't think there's anything I can do about internet latency, I'm afraid.
Yeah, I also think that's on your side, Jacob. I'm
Is it?
seeing it just fine.
Okay, that's weird.
Okay, let's see. So, what is the y in this case? Because I wrote y here, and then I'm realizing that I have no y.
0.49 meters.
Yep. 0.49. And then if I fiddle this around a little bit, that's k times 0.49 equals 9.8. So that would be k is 9.8 over 0.49, which makes me think they probably orchestrated this so that that's 2.
Yeah, that is my issue.
20.
Thank you. 2 up to a factor of maybe 100. Yeah, any arithmetic I do should definitely be taken with a grain of possibly plus or minus a factor of 10. All right. Was this making sense, or should I go through where I got the starting position for that? Like, did this starting position there make sense? Somebody explain where I got that from. It feels like magic bullshit to me, now that I'm thinking about it. It came out to 20, though, so it's got to be right.
What was the question?
Where did that equation come from to begin with? Why did I set 0 equal to the spring constant times the distance?
Oh, because the net force is 0, because it's at equilibrium.
Yeah, I'm really thinking, all right, so in the case that we're sitting at equilibrium, right, we're not moving. So I guess if I had to rewrite this, I would rewrite this as we're not accelerating because we're at equilibrium. We're not moving because we're at equilibrium. We have our constant and our 0.49 because we're at equilibrium, and that's going to equal out the force of gravity.
Because that right side is mass times acceleration, and mass is 1.
Yeah, yes, the right side is mass times acceleration. Yeah. Thank you. All right. So I'm going to put my spring constant in now. So I got y double prime plus 4y prime plus 20y is, and now I've got my external forcing is 8 sine of 2t minus 6 cosine of 2t. Like I said, 2t. All right, now what? Kablam. Springy bouncy business? I have a real problem. This equation has too many symbols. Go ahead, Bridget.
I was gonna suggest we solve for R. Like find the homogeneous solution. But I'm not sure about that now.
No, that's a great idea. Let's do it. That's a lot easier than this question. Right? This is actually one of the kind of beautiful things about DEs that I really like, is that a lot of these problems start with this like, dude, that question's real hard. Let me answer a dumber question first, and then I'll like once I'm stretched out and warmed up, I'll take this whole thing on. So our first thing is going to be to take the homogeneous equation. So we're going to have yh double prime plus 4yh prime plus 20yh is 0. Then we're going to make a substitution, which is yh is what?
R squared plus 4R plus 20.
Oh, yeah.
E to the
Yeah, good.
whatever. E to the RT plus
So just because some people are a little bit lagging on their work, I'm thinking the thing I'm doing is I'm substituting in e to the RT, and then I'm gonna take two derivatives, plug it in, divide by e to the RT. I'm gonna end up with this quadratic equation that I can actually solve. Oh, I just advertised that I can solve that. Can I solve that? How do you solve that? Oh no.
Wolfram, baby.
Perfect. Yeah, toss it in Wolfram, toss it in your favorite quadratic formula calculator, which, might just be your friend or whatever. Or you could complete the square. I'm going to complete the square just because I can. Something like that. That is r plus 2 squared is negative 16. So that is r is negative 2 plus minus 4i. Is that what you guys got?
Yeah. Every time I see complete the square, it just reaffirms why I hate it.
Yeah, for sure. I had such a deep and abiding hatred for both factoring and completing the square until I taught Algebra 1. And when I was done teaching Algebra 1, I was like, oh my god, it's no wonder people like this shit. It is a way faster if you're good at it.
Yeah.
All right, so however the hell you end up with this, I don't care about your I don't care about your technique here. I just hope you end up with this. And then what does this mean? That means YH is what?
E to the minus 2t times cosine 4t plus sine 4t.
Good. E to the minus 2t times cosine of 4t. Oh, maybe with a constant. So maybe.
Yeah.
Let me call that C1 just to be in keeping with the book. Plus C2 e to the minus 2t sine of 4t. Okay. Rad. Now what? What's my next goal? What was I originally working with? A bit ago I was working with this thing, right? Okay, and then I went and found Y homogeneous. And now if I'm looking at this, I'm thinking to myself, self, you need to solve that. That right-hand side is a problem. So far I've solved the right-hand side equals 0, but so what's the right-hand side made out of? Like categorically, what is that thing?
Trig?
Yeah, it's some trig functions, like some sines and some cosines. Okay, so hot question. What do you differentiate a couple of times, add maybe back to itself with some constants to end up with sines and cosines? For those of you also enrolled in linear algebra, this would be what space is closed under the operation of derivatives that has sine and cosine in it. So I'm thinking about a spanning set here, but with a real weird question. So what happens if you differentiate sines and cosines? What do you get?
Sines and cosines.
Okay, cool. Feels like I'm not going to get any surprises if I guess sines and cosines, right? So that's what I'm going to do. I'm going to guess my particular solution. And the particular solution I'm going to guess is yp is, well, I guess it's going to be a sine 2t plus b cosine 2t. Because, like, I've got sines of 2t and cosines of 2t. What should I be worried about? I'm a little worried that maybe those overlap with the homogeneous solutions, right? Like, that's why I solved the homogeneous one first. These are cosines and sines of 4t, not of 2t, and they also have this exponential piece attached to them. So I'm not worried about running into those. What would happen if they were the same?
They would all cancel out.
Yeah, they'd all drop off and I'd have wasted my time. So I know that at least I'm not going to waste my time doing this. So now I need yp prime, which in this case is relatively straightforward. It's just 2a cosine 2t minus 2b sine 2t. What's yp double prime?
Minus 4a sine 2t. Minus 2b cosine 2t.
Wait,
Oh, sorry, 4b.
did I have this wrong? I thought you couldn't do this because a sine. Oh, it's 2t. Oh no. I misread that as sine 4t on the right side, and I just did the worst derivatives of my life.
And also, it still wouldn't have mattered. So the thing that I'm concerned about is that the R's might overlap. So if you look at this carefully, these kind of things, right? These things would be the solution if R was plus or minus 2I, right? You guys with me on that?
Mm-hmm.
As long as those R's are different than the ones that you found earlier, you don't need the T's. So even if I had 4's in here, I would still just have plus minus 4 I's, and that's not the R I had before. The R for the homogeneous equation is negative 2 plus or minus 4 I.
Okay.
So even if I had those 4's, it wouldn't matter. They wouldn't overlap. I wouldn't run into problems.
That makes life a lot easier.
I hope so, yeah. All right, so let's plug these things in. Let's see. So what are my coefficients? 1, 4, and 20. Oh, gosh. All right, so now for the hell? Where's my mouse? All right, so 1 times, oops, that's the wrong button, times this thing. Plus
Yeah.
4.
Why wouldn't it be the yp double prime?
Oh, good call. Thank you. It would absolutely be yp double prime. It is important that when you're all excited about copy and pasting things, that you copy and paste the correct things.
You have the luxury of copy paste. So I was like writing it, and I was like, oh, what did I miss?
Oh no!
I had wrote all that stuff.
And with copy and paste comes also the you must write parentheses down. I'm kind of annoyed that I'm getting used to working like this just in time for this to not matter anymore.
I'm going to keep taking notes like this, so I'm glad that I learned it.
And I'm just going to squish that over nicely to have space. Look at that. Look at that. And then I'm going to go get this guy from up here. Okay. All right. The one thing I'm never going to complain about is I have actually legitimately learned how many meetings could have been emails and how many emails just didn't need to get responses. And that is going to spoil me forever. All right, so now we need to multiply out a little bit. So let's do some kind of careful collection of terms here. All right, so I'm just going to do this a little bit quick, but I'm looking for sine of 2t's. Where am I going to get sines of 2t's? I got some right here, I got some right here, and I got some right there. You see that? So I'm just going to collect those coefficients. So I've got minus 4a here. Then I've got a minus 8b here. That's from this guy. So that was thing 1, thing 2, and plus 20a. That is thing 3. And this is equal to 8. Everybody with me on this? Okay, and let's go through and collect the others. So I've got cosines, cosines, and cosines. And all told, that's going to be minus 4b plus 8a plus 20b equals negative 6. Let's see. And it feels like I can do a little bit of simplification. So I've got 8a plus 16b equals negative 6. And on the other one, I have negative 8b plus 16a equals 8. So bringing my two classes together again, that means I have an augmented matrix system that looks like this. Or otherwise solve this. I give no hoots. Let's see. So for me, just because I feel a little lazy on getting a calculator out, I'm going to take this first row and multiply by negative 2 down here. So I got negative 16, negative 32, and 12.
Joe, since it's a 2 by 2, can't you just use the 2 by 2 matrix inverse trick?
Sure. Hell yeah, let's do that instead.
I don't know.
That's a lot more fun. Let's do that. For those of you who are dolls, is everybody who's chilling here in linear algebra except Bridget? All right, Bridget, you're learning a new trick today.
Did it like a decade ago, but it'll be a good refresher.
Okay, you're relearning an old trick?
Relearning an old trick, yeah.
All right, so let's see. How do I calculate a 2 by 2 matrix inverse?
All I know is that you do the negative of one of the diagonals and then switch one of the diagonals. I can't remember which one it is. Oh,
okay, so
I was doing a different trick.
No, you're right.
Well, yeah, well, you were doing the determinant. I was just thinking of.
Oh, you need the determinant. That's part of it. You have to divide by the determinant. So the matrix flip trick is going to look a little weird in this case because it's the two things on the diagonal exchange places. So I'm going to write negative 8 here. That is actually this negative 8 down here, which is do-si-doed with its neighbor, this 8, which is now down here. And then on the anti-diagonal, I'm going to put a minus sign on both things. And in this particular example, that's kind of shit because it looks like I just made negative the whole matrix.
Yeah.
But I did two different things. The main diagonal was a do-si-do, and the anti-diagonal, each thing got a minus sign. And then in here, I need the determinant, which is 64, negative 64, minus, what's 16 squared? 256?
56.
Thank
That's
you.
the determinant of your original matrix, not your augmented matrix.
It is, yeah, determinants are defined
Here,
for
but-
matrices.
Okay.
So that's the determinant of this matrix. And then I'm going to take this whole thing and multiply it by negative 6, 8. And in the end here, you're going to get numbers.
They're going to be very ugly numbers.
Is there any way to add programming into this?
Yeah.
Can we show that? No, I'm just kidding.
Well, no, let's...
Well, I only have like 9 minutes till I have to go to tutoring.
Okay, so here's Repel. I need my matrix calculator. Let's see, that was linear algebra basics. Okay, let's see. So that's how you make a matrix. Okay, so we can make the matrix B, so we'll turn that on. Let's see. Our matrix B needs to have our other thing in it. So I just need to be able to see both of these. Okay. All right, so I'm trying to solve this equation, right? So I'm going to actually be just a little bit lazy here. I'm just going to put this matrix in. So that's the matrix 8, 16, 16, and negative 8. Okay, let me comment that guy out because I don't need it. I'm going to bring that in. Oh my, this is a lot of pains, isn't it? Okay, so right now I'm reading in the matrix that I was looking to solve. Okay, the matrix B is, oh, something weird is going on. All right, we don't need that. Let's see, oh, an inverse. Excellent. We're gonna need that, but we need the inverse for B. Okay, there's B inverse. That was a lot faster than the 2x2 trick I was doing, right? Let's see, and what we need is B inverse times this little vector. So I need to make another matrix. I'm going to call this vector C, I guess. And C just wants to have two things in it. The two things it wants in it are negative 6 and 8. And then we're going to copy this and change both things to C. Okay, so it looks like I've got matrix B, I've got matrix C. Now I want to go down here. Let's see. Okay, so you multiply using this dot thing. Oh, yeah, to multiply. Okay, so let's bring that in. And we want B inverse C, right? So I need B inverse here. Well, that was this thing. And then I need C here. Damn it, Karen. Oh, he was wrong. There's only 1 5 in the second half. All right, good. So I got my two numbers, which are 1/4 and negative 1/2. So to answer your question, yes, there's always a way to combine all three classes. So I got out of this a quarter and negative 1/2. Now, what do I do with that information?
So your C1 and C2.
Close.
That's your A and B coefficients on the sine and cosine.
Yeah, those are A and B. So I go back up here to where I was making guesses, right? So I've got my two pieces of information, and so I want to combine them. And so now I claim that I now know what Y is. Y is the homogeneous piece. Added to the particular piece.
Jesus.
And now you guys are really regretting not having copy paste, huh?
I have it, man.
And these are, let's see, A was a quarter and B was minus 1/2. Roll call.
Now we just need to solve for C1 and C2. I don't know if we actually have to do that, but
They didn't give me initial conditions.
did they not?
Yeah, they asked me for the steady state component.
Oh.
I guess I'm not really sure what a steady state component is. You guys see that? Okay. I'm trying to be a little bit more honest about, like, sometimes I don't know things. I Google them. Don't be afraid to Google things. Like, it's fine. I don't know computer science shit all the time. I just Google it. And you know what? If you can read and you know a little bit, Google's a really great tool. Somehow, I haven't been demonstrating that in classes. Now I am. It's rad. Let's see. Steady state in electronics. I want a steady state component of a spring. Oops. That is not how you spell the word spring. If you Google things and can't spell them, there is a problem.
You spelt it wrong again, but
Shh. The steady state response is okay. Yeah, I believe they look horrible. Thank you, friends. What is the the second term gives the steady state response. So the second term being the particular solution. So in the end here, they wanted just the steady state response. And so that is this guy.
So we could have skipped doing the homogeneous portion. Like that's not really needed to answer the question, I guess.
Ish. So we used method of undetermined coefficients, right? In using method of undetermined coefficients, the first thing that I went and did was I looked at the R's from the homogeneous solution and made sure they didn't match the ones that I was kind of guessing.
Okay.
So broadly, yeah, if you're just looking for a steady state, you don't necessarily need that thing. However, in order to do method of undetermined coefficients, you need at least most of it. And this is one of those cases where I guess I would say I'm going to err on the side of writing the one more line. It's like after you've found the R's, right, it's just a matter of plugging them in, which is no big deal. So, but yeah, strictly speaking, you didn't need to. And also, you could have just made your particular guess, tried it, and if it zeroed out, then you could have gone back and slapped a T on it and tried it again. I find that to be so devastating, like to my morale, that I always do the homogeneous thing first and then check it. But you're a person. If you don't find that devastating. You don't have to do it that way. Anything else about this problem? Okay. I am killer excited to have been able to stitch all 3 classes together. Yeah. Thank you guys for coming to Zoom class today. It's much appreciated.
Thank you.